Welcome to this video in which we'll discuss some of the unique features of Cross. My name is Harry Bakshi and I'm a solution architect at Cross. We're going to highlight two topics. The first of these is the way that Cross integrates data and the difference between integration and federation. Then we will see how Cross handles variable quality data. Perfect data sets are not required. Cross can take what's there and work with you to improve quality over time. On to the first of our topics, integration and federation. What do we mean by this? Well, when Cross ingests data, it goes through a process called cross-domain mapping, where it fully links all the data from all the different layers to each other. Now this is a vertical integration, so we know for every service, be it IPVPN, Ethernet or a PON, which underlying physical resources are used to carry that data. And this connects the logical service all the way down through the fiber to the patch cord and patch panel. The alternative to full integration is federation, and this is where data from different datasets are overlaid on a map but not fully connected. Let's look at an example of this. This is a typical federated view. You have a logical connection from this home to the exchange, and you also have the physical path, fibers, splitters, and connectors. But the two are separate. You know that this is a logical connection, and you know there is a physical path. So you can assume that this logical connection follows the physical path, but there's nothing explicitly telling you that. And there's no indication of exactly which path is followed, which patch cords, which ports are used. The alternative is a full integration, where we have the same link, but in this case it explicitly follows the physical path. The routing information for that logical circuit provides full details of the underlying physical network, every connection, every patch. And these explicit details are also available in a schema, which provides a full stack view, top to bottom, of the logical circuit and every element it crosses. This ability to connect and integrate all available data is unique to Cross, and it's the underlying technology behind some of our more advanced features like service impact analysis and root cause analysis. The next thing we're going to discuss is Cross's ability to handle variable quality data. Now this can be missing data or data that's just plain wrong, what we would call dirty data. In this first example, we can see a good circuit. Now this is a circuit that's fully documented. In this case, the consumer-provider relationship is fully documented between every layer. This is the ideal case, and if all of your circuits look like this, well, we're off to a good start. But in reality, most operators have gaps in their data. In the next example, we can see a top-level circuit described, but underneath it, there is no information. So we know there is a circuit joining these 2 points, but we don't know anything about it. Cross can still work with this. It can set up the top-level logical circuit and make it available for higher-level services to use, for example IPVPN. This is quite common in operators that have mobile networks where the backhaul or RAN is outsourced. This is managed by data quality rules configuration. This is where we can assign a quality level to the node type. So while a logical port, a network element, or a VRF termination could be quality level 2, if we only know the location, that's quality 4, and in between we have 2 and 3 for rooms and buildings. These quality levels are then reflected when you create the link or circuit. The final example is a hybrid, where we have most, but not all of the information. You can see from the screen we have certain connections which are highlighted with red dots. One of these is a logical connection, the pond path, and the second is a physical connection, the trench or conduit within which the optical cable runs. Cross highlights both of these and gives the start and end points of the gap to enable you to identify exactly where remedial action is needed. Finally, we have data that's inconsistent or just plain wrong, what's sometimes called dirty data. A very common example of this are IP addresses. It may be that there is a valid change in a node's IP address, or it may be that the data we're pulling from a dataset is wrong. This is particularly important when we're getting the same data about an object from two different datasets. The cross-synchro module handles this by checking the new information against the existing information, and where there's a discrepancy, flagging it for operator intervention. Thank you for following along with this video, where we described two unique features of CROSS that are unavailable anywhere else. If you'd like a full demonstration of CROSS, please contact us and we'd be happy to arrange this for you.